One can save money with two different methods. So, one of the methods is if you have money, you can do what's called a lump sum savings. You throw it into a savings account and it saves compound interest over a period of time. And the longer it stays in there, of course, the more interest it earns. But very few people have, $25,000 sitting around that they can put into an account and then just let it grow in interest. Most people do what's called systematic savings, and generally they put money away from every paycheck. So if they're paid weekly, they put a little bit aside weekly. If they are paid monthly, they'd put it aside monthly. Generally, we're going to be talking about monthly savings. So if we're going to be doing monthly savings, we're going to have monthly deposits. So, on the one hand, lump sum savings, to be really clear about it, there is only one deposit. You're only going to deposit money one time, and then you just let it sit in there and gain interest. Systematic savings, on the other hand, is multiple deposits. Um, the only thing that we're going to require for most of our discussion um, is that these deposits are equal. Now, if you use a spreadsheet, it doesn't necessarily have to be equal deposits. It could be a little bit here, a little bit there, and then you can use a spreadsheet to track it and the amount of interest you earn. So that's where we're going to start with. We're going to start with what happens when you make monthly deposits. So let's say we have a savings account at a bank, probably like a CD, not a normal savings account. CDs offer a little bit higher rate, and I think I've discussed these before. They lock in the money, so it's a little bit harder to pull it out because you're penalized with fees, and therefore the bank feels like you'll leave it in there and give you a higher interest rate. All right, so let's say we have different monthly deposits, and then let's see what happens as we do a systematic savings account. So let's let zero represent the initial deposit. So our monthly deposit, let's say we were going to put in $250. Now it's not going to gain any interest on that first month, so our balance is just going to be $250. So let's say on the second month, we couldn't put in as much, so we put in $200. Now, it's going to earn interest from here. This amount of money, $250, was in the account for 1 month. Therefore, it's going to earn 1 month of interest. So when I get to my interest, it's going to be $250 that was deposited. The interest rate is 4.5 out of 100. And the time frame is just 1 out of 12. Kind of like with the loans, it works exactly the same way, except in this case, instead of just the payment going towards the balance, the interest is going to go towards the balance also. So instead of one giving and the other one taken away, these are both being given to the balance. 250 times 4.5 over 100 times 1 over 12. There we go. So we're earning 94 cents in interest. Yay! Doesn't sound like a lot, does it? So this would be, the interest is 94 cents. So therefore my new balance is going to be 250 and 94 cents. And the answer is, well, kind of, but then we're forgetting that we made another deposit. So when we get to what is the balance, we have to be a little bit more cautious. So I'll do this in red. So we're going to get the original balance, which is 250, plus our new balance, which is 200, plus our interest, which is 94 cents. So that's a grand total of $450.94. Okay. And then let's say we get to month 3, so another month has passed. The balance now is $450.94. And let's say we deposit $500 this time, just for fun. Therefore, the interest is going to be on our balance, which is 450.94. It's going to be times 4.5 over 100. It's going to be times 1 over 12. So 450.94. And notice the other two things aren't changing, so I just have to change the balance. So I'm earning now $1.69. So this would be $1.69. And when I get to what is my new balance, I'm going to have to add the previous balance, so 450.94, the current deposit, $500, and the new interest, $1.69. So plus 500 plus $1.69. So our new balance is now $952.63. All right, so it seems like our account is increasing in value rather nicely. All right, so let's say one last time. Let's deposit $300. We're going to earn interest on the previous balance, so it'll be I equals 952.63 times 4.5 out of 100 times 1 over 12. 952.63. 952.63. So now we're earning $3.57 in interest. So this would be $3.57. So I hope you see what's going on here. The interest started off at a small 94 cents, and we're like, why even bother having a savings account? But as time goes on and we keep depositing money, the amount of interest that we're earning is increasing and increasing compoundedly, which is kind of nice. So you're earning money on money that was interest to begin with. All right, so when we add that on to the 952.63 plus the 300, we are now up to $1,256.20. 12562. 125,620. And this would be our balance in our account after saving money, in this case, for 4 months. Not a bad deal if you think about it. So instead of borrowing money and paying the bank back plus interest, here the bank, you're kind of paying the bank, but the bank is paying you interest. So the interest, instead of paying to the bank, is now being given to you. And this is why systematic savings is really probably the best way to purchase things. So there is, again, a formula for finding the balance of an account after multiple deposits. And actually, one of my letters is wrong here. This is the future value of the account. D being the deposits, N and R and T are all the same things that you're used to with compound interest. So if you wish, you can use this formula. But I highly suggest, instead of trying to figure out how to type all that junk into your calculator, you use a calculator that I've already developed. So for instance, all right, so let's say you are going to save $150 per month into an account that earns 2.5% interest. how much money will the account be worth in 5 years? And I'm going to change it to 10 years to show you that it's not just going to double in amount. So this is my calculator, systematic savings calculator. And again, if you want the link to it, I can send it to you. Boy, that cardinal's really loud. So we're going to deposit $150 every month into an account that earns 2.5% interest. And we're going to keep it in there for 5 years. So this would be 5 times 12. And that gives you 60. And it'll just tell you what your accumulated savings are. So it'll be $9,576. $9,576, and I think it was 8 cents. All right, so what about 10 years then? So you're thinking, well, you're making deposits, the same amount of money per month, $150 per month. You're earning the same amount of interest. So the amount should just double and we'll end up with about $19,000. So my guess is doubling what's up there. It'll be about $19,000. So let's see what happens. So instead of 60, this would be 120. That would be 10 times 12. And it turns out to be $20,000. So it's pretty close, but it's not exact. So 20,425. 20,425. And I already forgot the pennies. So it's like $1,400 more than what you had expected. And where that money is coming from is the interest that is accumulating as time goes by. And as your balance gets bigger, you're going to earn even more interest. So in the next 10 years, if we go to 20 years, it's actually quite amazing how much money this turns into. Remember, it's only $150 a month. It's really not a horrible lot of money, but it still makes a lot of money when you talk about over time. So that would be 240 months. And now we're talking about 46,646. 46,646. Oops. And I'm not going to worry about the pennies this time. So again, it's more than double, and that's because of the interest. So my suggestion to you is if you are willing to wait to buy something, I know how most people are like, gotta have it now. But if you're willing to save the money systematically, you'll be able to buy the thing outright and never pay interest on it. And the bank will even give you a little bit towards your purchase. So this is generally the smarter way to buy things. And even if you don't purchase it totally outright, you can come up with more money so that you're lending or borrowing less money when you do purchase your item. Now, one of the more common reasons to save up money in a savings account systematically is for the down payment of a house. Because the bigger the down payment you have, the better interest rate you will be getting, and the less money you will be borrowing on a mortgage. So how much money should I save every month into an account that earns 4% APR to come up with a $20,000 deposit for in 5 years for this down payment on a house? So again, we're going to have to use a calculator. We could use that ugly formula, but it gets kind of messy. So if we go to another calculator, this one being monthly savings with goal. So on the top line, this is our goal up here. So I want that to be $20,000. Now be really careful with the number of zeros you type in, because if you are one short or one more, it's going to throw your answer off. The interest rate, not as a decimal, but just as a number, 4%. and we're doing this over 5 years, I think 60 is right for that. All right, so the monthly deposit you have to do over 5 years to generate $20,000 in this account will be about $302, 301.66. So that would be how much you would pay per month. All right. So if that's how much we're going to pay per month, I'm curious how much of this $20,000 is coming from interest. So let's ask a question. How much of the $20,000 that we're going to be saving is from interest? All right, so to find that, we go back to those, what I like calling the common sense formulas. We know that we're depositing $301.66. If you're smart about it, you would just deposit 300 or 302. We're going to be doing that for 5 years, and every year has 12 months. So this will tell us the total deposit that went towards the $20,000. And you'll find that this calculation is not going to be equal to $20,000. 301.66 times 5 years times 12 months. It's only 18,000. So this is the amount of money that came out of your pocket, or so that doesn't answer the question, how much interest? But this tells me basically the principal of the loan, and then the future value of the loan is that $20,000 at the top. So to find the interest, it's going to be the future value minus the amount of money that, came out of your pocket. So here the interest is going to be the $20,000 that you saved up minus the $18,099.60 that you actually deposited. And that'll tell us, I'm going to do a backwards calculation here. So the amount of interest we earned on this account is $1,900.40. 190.40. So this is interest. The amount of money that the bank paid you for letting them hold on to your money. Not bad for just 5 years. So at this point, we have all the calculators that we need and formulas to talk about retirement savings. Now, retirement savings is not the easiest thing to understand in the world. It's not as straightforward as any of the other things that we've been doing because it basically merges them all into one type of problem. But generally speaking, retirement savings, you're going to do two things. You're going to systematically save up money while you are working, while you're making money, to come up with a nest egg. So you're going to set aside some money every single month, and your nest egg is going to grow to be a certain amount. Now, we're going to do this systematically, which means our deposits are going to be constantly exactly the same. Of course, most suggestions for retirement is as your living ability becomes more comfortable, generally when you're young and first get your job, you're just getting started, and a lot of your money is going to go towards your upbringing of your children, your house, and stuff like that. And as you get older, your responsibilities on that end are going to reduce, so you can shift some more of your money towards retirement. So we're not going to get into that complexity. We're going to kind of keep it simple. You're going to save a certain amount of money every month. It's going to earn interest. Your nest egg is going to grow. Now, After you've grown your nest egg and you think you're all ready for retirement, you retire, and then the nest egg is actually kind of like money that is borrowed from you. You become the bank in this case, and then that account is going to pay you monthly payments. Just like if the bank borrowed money from you for a car for themselves, they would pay you monthly payments, just like a loan. So when we're talking about these two things, this one up at the top is obviously the systematic savings formula, but there's two versions of it. One is how much will we need? So that'll be the systematic savings of knowing the amount of money you need to save up. So that last calculation that I did. And then we're going to use systematic to build using that constant deposit that we just found up to our nest egg. So we're going to build to the nest egg. I'll just call it nest. All right, so once we know how much money we have to deposit every month, we're going to build it up to our nest egg. So the question then becomes, how do I find out how much I need for retirement? There's different philosophies about that, but I'm going to keep it simple. All right, then the second part of it here, this is going to be a loan calculation. So you're going to find out that this account is going to pay you, and as it pays you, your balance is going to go down a little bit, but then it gains interest on whatever the balance is left. So this is generally how a retirement savings account is going to work. So we just need to take care of a few things. So this example is going to take a little bit of time. So if you have to go to the bathroom, do it now. Pause the video. This is not as nice as any of the other problems. There's a lot of pieces to it, but as long as you keep things really clear, the pieces come together rather nicely. So Josie works for 35 years. She started working in 1985, and that's when she started planning for her retirement. She figured she'd need about $2,500 a month. Harvey? Shh. Noisy dog. Now, this $2,500 a month is not the amount of money she really needs in the future, because we have this idea down here of inflation. So it's $2,500 per month in money in 1985, and money in 2020 is different because of inflation. It's worth less, so she'll generally need more. So that's what she needs from her nest egg, and she thinks it's going to last her, or she'll need it for 20 years. Now, after you retire, you only need money until you die. So she's kind of assuming that when she retires, she'll only live for 20 years longer. And that's a hard thing to judge, but people do it differently. So we have all the information we need. She's going to work for 35 years. She knows how much money she needs a month. She knows it should last her 20 years in retirement, and we have a nice inflation rate. So one of the first things you should do is find value needed in 2020 money. So to do that, when we're talking about inflation, inflation always has this per year attached to it. So it is compound interest because we have that 2.5% per year. So the first formula we're going to come across is the compound interest formula. We haven't used it lately. It's kind of nice to bring it back. A little review. All right, so the future value is what we're looking for. That'll be the value of the money in 2020. So we're looking for him. The present value is how much she's expecting per month, which is the $2,500. 1 plus the rate of inflation divided by 100 is this, 0.025. And n, because it says per year, n is just equal to 1. So we'll just get a 1 there, a 1 there. And the time. Now this is, you'll see 2 times in my problem, one being 35 years and one being 20 years. You have to keep them separate. 35 years is how much she's saving up for, and then after that, 20 years is just how much she's, paying out of her nest egg. And we're trying to figure out how much she needs per month for her nest egg. So we're really talking, she's looking at money, its value in 35 years. So time is 35 years. So make sure you type this in your calculator to see if you come up with the same answer that I do. You might want to pause it so you can go, yes, I did it right when I write down the answer. So in 35 years, she is going to need $5,933, and I'm just dropping the pennies because that's not important. This will be per month. So $2,500 in 1985 equates to almost $6,000 a month 35 years later. So this is the amount that she needs to be paid from her nest egg. So basically this becomes, in a better way of talking about it, since she's being paid, or the account is paying her this much money per month, this part is going to be a loan. So you're basically getting payment for a loan of the nest egg of this much money per month. All right, so then the next question is, to generate this much money per month, and this is where the 20 years is going to come into play now, we have to have enough money in the nest egg so that when we start pulling money out of it, it doesn't deplete itself too quickly. So the next part of the question is, how much of a nest egg do you need? And where the nest egg is coming from is the systematic savings. So now I need to know how much of a nest egg Josie needs, and I know how much money is going to be paid out of this account as a loan. So what we need to do is find the maximum loan amount. So she'll have enough money in this account to make monthly payments to herself, and then at the end of 20 years, the balance would be 0. So I need to use my maximum loan calculator, and $5,933 a month. So my payment is going to be $5,933 per month. The interest that we're going to earn in this account, I didn't set it. So let's make another assumption. Bank, APR, let's say she can find an account that earns 4%, a CD, a savings, mutual fund, something like that. So I forgot to put that in there. There we go. So then my interest rate is going to be 4%. Don't get that confused with inflation. Inflation rate is just how much money is worth in the future. Interest rate is how much money your account is going to earn in interest per period. All right, and then of course we're going to need time, and time in this case is going to be, I need a maximum loan so that it'll pay out almost $6,000 a month for 20 years. So this will be 20 years of retirement. Okay. So now I use my maximum loans. See, max loan, boom. And I know my monthly payments are 5933. I know my interest rate I'm giving myself is 4. And I know this is going to happen for 20 years times 12 months a year. So my nest egg, or I'm sorry, Josie's nest egg, has to have almost $100,000 in it. So 979,075. So this is the amount of money she needs to have in that account so that as she pulls almost $6,000 a month out of it, it'll earn enough interest to offset that, and the account will run itself dry after 20 years. So far, the first two steps were finding out how much money needs to go into this nest egg. So we had to find out how much money she needed per month in the future, and how much money that would require in a nest egg so that she would have enough money to live off for 20 years in retirement. So now we know that she needs this almost $100,000 in savings to survive for 20 years without running out of money. So the next part of it is, how do we generate this nest egg? So here we know how much money we need to save up. We know how much time she's going to be saving this up. And we know the interest rate of the account that she's going to deposit this money in. So we're assuming she's depositing the money in this account and she's pulling money away from this account, and both of them are earning 4% interest. Well, this calculation is going to be, how much money should she save per month to generate this amount of money? How much money she needs to save per month to generate this amount? So we're going to use a calculator. We're going to be looking for monthly savings with goal. We know that we need 979,075. We know the interest rate is 4%. We know we're going to be saving this up for 35 years. And then don't forget the times 12. So the amount of money she needs to put away every month to save up for her retirement is $1,072 if we round it. Write this in. $1,072. Required deposit per month for 35 years. So you can see now that saving retirement is a major sacrifice for most people at the beginning of their careers. But by the end of her career, she'll be making closer to the amount of money she's expecting to get, so she could actually save more money. So generally, when you're doing this, you don't save $1,072 a month. You start off with a little bit and you increase it to be actually more than this as you get closer to retirement. Now, just for fun, let's figure out how much money is coming from her deposit and how much money is coming from interest for this account. So we'll start off with our monthly deposit. We'll times that by 12. We'll times that by 35. So let's see here, 1,072 times 12 times 35. So the amount of money that came out of her pocket over the 35 years was this, 450,240. So anything above and beyond that to get to that 979,000 is going to be interest. So if I subtract the 979,075, she's earning an interest. The bank is paying her just for the first 35 years. We're not talking about the 20 years of retirement, how much interest that account is earning. she earned $528,835 just in interest. So more than double of what she deposited herself. So this is why savings plans are really important.